Cute. And I've got the notes just started. Yeah, does anybody have announcements for this week or things you want to?
Yeah, I was thinking of maybe just showing that title page for the user tutorials and just have everyone take a first glance and see if they like it. But I'm just going to need a minute to open it up, so I can maybe not go first.
That sounds good. I think BCGS is this coming, not tomorrow, but next week. Is that right, Dom? Oh, you are muted.
Correct. Yeah. Thank you for the reminder. It will be on. Yeah, the 24th at 4:30, either in person or on Zoom.
Awesome.
It's Brendan Howe from Tech.
Excellent.
Oli's on.
Hey, Sagi.
Hey guys, long time no see. Well, I've seen you at that, not a long time.
But nice to
So,
see you.
well, we could. Sadly, I could see the sort of like familiar. What is that map? I think no, it's not a map. It's like a geologic history still there.
Awesome. Cool. Okay, well, if there's no other announcements, I don't know who wants to kick things off.
Yeah, I brought it up, so I can show it now. I need screen sharing powers.
You should now be able. Oh, I think
Oh.
Joe just clicked and then unclicked the same thing.
Okay.
Sorry. There you go.
So let me get this. Yeah. So yeah, moving the user tutorials outside of where we have the code base. This is just kind of a landing page, and we can do all sorts of fancy configurations, but it's just kind of starting out with who should actually be here and saying you need to install SimPEG, and this is kind of what we're doing, right? So what are these? What can I learn from them? How do I access them? So probably the questions people would want to answer on the landing page. A little bit of a caution. So we have a lot of admonition options, which is cool, but just trying to make sure that people know if they want to guarantee everything works properly, they need to keep their version of SimPEG up to date. So a little explanation of what those tutorials are. And I made this graphic, which I thought was pretty sweet. It's basically, we've got SimPEG and then we're creating a website with Mist. And the power of this is that people can read through the material, download it, run it, and then alter it. And so the things that we can learn is quite a lot. But if you want to have a complete knowledge, you need all of the pieces of this puzzle. And so I guess I was going to focus on what is the actual physical thing these objects represent, because each thing kind of corresponds to either something mathematical or something tangible like a receiver. Creating these objects, using them. So what are the different things we can do with something once it's created? And then the big thing that we're going to use to augment these is suitable input parameters. So things like, well, how big should my cells be? Stuff like that. And so we go through that, elaborate on it, and then accessing them. Well, a little explanation of the organization, and that, you go to the top and click this button to download. So I don't think there's really anything more that needs to go on this landing page. I think more content might spill over into some of the other stuff we're doing. And then maybe just to give you a sense of one thing that I do want to add is with these admonitions at the top of each one of these notebooks, I want to put something that tells you whether or not it's a really lightweight tutorial that you could just run in the background while your computer processes are running, like just a 1D Ford simulation is nothing. We have some medium weight notebooks where you know, as long as you've got about 8 gigs of available RAM, you could run it on your computer, but it might take a few minutes. And then we have some computationally intensive ones once we start putting in things like 3D EM inversion, where you would probably have to have access to some form of cluster computing. So to just make it clear that these are laptop examples, and then these are full examples that are like very advanced, I want to be able to put that right off the bat. So this is kind of where I'm going with it. So I don't know if there's any just like off the top of people's heads comments on this. But
One thing about that kind of, since you're saying like, okay, make sure your version of SimPEG is up to date. I would be very forward about this was all run on SimPEG 0. Whatever. Like, make it very clear to everyone who's running these notebooks when they were like what version of SimPEG they were most recently ran with. And
yeah.
One thing that can be done with that is at the bottom of every notebook to include that SimPEG report function. I don't know, Devin, if you've seen that before.
No.
Peter did this. So if you do from SimPEG import report, just capital R report, and then if just at the bottom cell, if you just do report brackets, it'll print out basically the version of SimPEG, the version of NumPy, all of those sorts of things. So that would be really nice to just, and then it's nice because it's automated. You don't have to go in and like every time we update the website, update that. It would be updated every time it's run.
The other, does it also output things like runtime? I know there was also some other kind of output information we were interested in.
I don't think it does runtime. I think it's environment.
Okay. I mean, that's something that I'm wondering if there's an easy way to sort of automate it on this page, although this is a markdown and not Python.
Does something actually run those tutorials to generate the outputs?
Yeah, I guess on each tutorial, that report would be able to provide that information, but it might, well, I'll play around with it, but it would be nice to also have something like that on the title page that says, you know, the current version of SimPEG is blank. It sounds like that's something people want right away.
I mean, I guess I'm curious how much of this is automatically built for you? Is it driven from a GitHub actions? Is it driven from just somebody writing all of these and pasting the images in? How does the Mist? I'm a little unfamiliar with how this is built itself.
I mean, building this thing takes no time whatsoever. My understanding of this is like you run the notebooks and then you save the status of that notebook, and then when you run Mist, it builds that. So when you're building the website, it's just building it from the current status of those notebooks. So if I did like a, I don't know, restart and clear all cells, and then I ran Mist, I'd have no outputs on that page because I've gotten rid of all the outputs. It would just be code. At least that's how it works with JupyterBook, and Mist is building it in a JupyterBook style. Yeah.
I think you should be able to insert a code cell basically at the bottom of this, or like Python code, just like you would in a JupyterBook. But we can play with that.
So in high level, are we pulling out the SimPEG tutorials from main SimPEG page, or is that like Oh, I see. Got it.
Yeah. Yeah, that's the idea is they take forever to run and they're limited to being as lightweight as possible. And now there's a demand to actually implement sort of best practices or rules of thumb. And so I've got a current like 3D frequency domain forward modeling in SimPEG, which takes several minutes to run, but the mesh is so coarse that the numbers aren't really accurately reflecting the response of the target that I put in. So now people would actually like to get realistic numbers, which means that we really have to take that out.
Got it.
Yeah.
Something we're definitely going to have to be conscious of as we're removing all of these things is that implicitly a decent amount of stuff within SimPEG is tested by running these tutorials, which is not a good thing. But we need to be aware of that and actively fix that in a similar time frame of removing these tutorials.
So you're kind of saying that if the coverage from like the unit tests isn't actually complete and sort of relies on some of these tutorials to be working.
Yes. I'm not saying that I would block removing the tutorials because they're like, we need them for testing. Like I'd be fine with removing them. We need to be aware of things that are no longer being tested and then do steps to fix that after.
Yeah, I guess the first step is building this resource, and then we would be able to start removing the old one, and maybe we do it sort of part by part instead of one giant delete. But that's a good point. Anyway, that's what I've got so far. There's progress being made.
Who wants to go next?
I haven't heard any issues related to 0.20. At least it seems like it all got pushed out last week and distributed to everything. Not really too much SimPEG related, although I've been looking at trying to get like a fast marching method for iconal equations, and which would be an interesting addition because we just have like straight rate tomography right now. Doing that kind of thing would probably be pretty useful. I know Lindsay and we chatted with a student who was interested in travel time tomography. Just one of those things. I was like, oh, that would be an interesting thing to add in, and I have somewhat an extensive use for it myself.
So Joe, are you going to build from scratch, or like are there some Python packages already? Are you going to wrap it up, or what's the
they're mostly applicable to like tensor meshes. So I've been trying to think more abstractly about how to implement it towards, octree meshes, which I think would be a really good thing. I haven't been able to find anything related to octree meshes with like fast marching iconal equation solvers. Should be interesting. There's a few things out there on tetrahedral and triangular meshes implementations for it. But yeah, most of the Python stuff that's out there right now is the structured grids.
Yeah, that would be great.
On a related note, I actually met with that student again yesterday because she's interested in doing basically using DAS cables and trying to get out like stress from engineering, geologic engineering, trying to get out stress from travel time, like get out the velocity and then infer something about in situ stresses. So she actually went through our code, and I was like, it was one of those humbling experiences where she's like, can you tell me what this line is doing? And look back and it's like, ooh, our variable names are O and D. This is useful. So actually what I think We eventually sorted through it. It was kind of a cool debugging, go back in time exercise. It is, you know, I think it's doing what it should be doing, but I anticipate we'll actually get a pull request from her as a first pass, just fixing all the variable names. Because I said, before you go ahead and try and implement something in 3D, let's just write out like everything that you think is going on. So I expect we'll have a pull request from her at some point. She's brand new to contributing. And so she might need a bit of support in that, but pointed her to a few things. And it's a nice place to start. Is just go in and fix all the names. So
Is she looking through the straight rate tomography stuff?
yeah.
Okay.
Where is that module? Straight rate, Como?
In seismic.
Seismic. Wow, never go there.
Yeah.
I was like, we have that? What?
Yeah.
Oh, I knew we had straight rate, but yeah, never go there, and nothing's commented to, right?
Yep.
No dog strings.
But the plots that are in there are actually extraordinarily useful. That's how we figured out what on earth is going on.
Oh, yeah.
So, yeah.
There are plots, sorry. Where
Or
are the
there's
plots?
some plotting code that normally we wouldn't include in a forward simulation, but I was very grateful it was there yesterday.
Huh.
So
Yeah, that's cool. Oh yeah, look at that. Survey.
It wouldn't be too much work to extend that straight rate tomography stuff to an octree code. The octree, because the octree meshes have functionality to find cells along the line.
oh nice. Yeah.
It's okay, query all the points along this line.
Do we have
And
that?
those
For...
are,
Oh, sorry, go ahead, no.
I don't go for it.
I was actually going to say, do we have that also for a tensor mesh? Because the way we figure out the ray going through a cell is actually, that's where I got tripped up. It's pretty subtle actually how that code in there currently works. And I don't think it readily extends to 3D actually.
Interesting. Yeah, I mean, I think so.
Okay.
I mean, not exactly, there's not like a get cells along line function. But if you're curious how it extends to 3D, actually, you could look at the line segment, line current segment station, because that does that. Like, okay, find the cells along the line path, and then it gets the edges along those cells and stuff. That would be how to go about that process.
Awesome. Thanks, Joe. Anything else? No,
Else.
fair enough. Who wants to go next?
Can go next. I'm still in time domain, and find ways that we can really speed things up for the fields calculation and the sensitivity calculation. So it turns out that when we compute fields, we step in time, right, over all the sources. But if the waveform, we're basically doing a lot of computations and at the end multiplying by 0, because often the waveform is not 0 at the beginning, but after this we have a lot of time steps that it's a 0 waveform. So our right hand side is just returning 0 arrays constantly. So I think it makes sense that we check first before asking for the right hand side if what's the status of the waveform for that at that time, right? The question is, currently it's very flexible. Technically, each source could have its own waveform, but in most cases, it's always going to be the same function, right? It's like an airborne survey and we have a single waveform and just going to be repeating it. So I don't know if it's a dangerous thing to do, or because the most efficient thing is that as we go down the time steps, we just skip the time step completely. If we can look down one of the sources and say, what's your waveform and what's the value of the waveform at that time, and just skip over completely, and that like spin things up a lot because we don't need to do a ton of array multiplications. for each sources.
You'll need to
So-
march the solution forward in time. Just because the source is 0 doesn't mean you can skip that the time step.
It's for the right hand side, right? When we compute.
Right hand side.
Sorry, what did you say?
Yeah, for the right hand side stuff, we still have to, like, we don't get to not do a matrix solve or something.
Well, we can go down the rabbit hole, but there's basically a lot of array multiplication. It's not a solve, but there's a lot of array multiplication happening over a loop of sources, and the loop over sources can be quite expensive if we have a lot of sources. So we're wasting a lot of time there. And also when I'm not sure how that works for JVEC, GTVEC, but when we're doing backward, when we're moving backward in time, if the data is not within the time range, we don't really need to compute the sensitivities for that data, because we haven't marched in time, to it yet. But I'm not sure how that looks though for if we don't store J matrix. But anyway, some interesting caveats there.
Would it be helpful if, like, on the survey for the time domain object, we basically created a latest waveform
Right.
property or something like that that could loop over the sources, so kind of keep the safety, but just do it once. And then basically then we know, like, this is the latest time that we'll have an active waveform, and after that we could switch off the computing of the.
So it looks at all the sources in the first pass, looks at all the waveform for all the sources, and then yeah. But what if they're, I guess they all have to be stepping the same way though, right? Like the DT, yeah, has to be shared across. Yeah.
Yeah.
But there's an off time property for all of them. So if we just did a quick scan
Yeah, one
all
loop
the
over
waveforms and then just say this is the latest off time, and then we can ignore
the after.
Yeah,
You could-
Roman lost this conversation before because we're interested in modeling UTEM, where the period of the waveform can be different by like a factor of 10. And so in order to model that with the same time stepping, it's like 0 time steps. And then like your waveform starts. So there's like a lot of redundant calculations. So it would be useful to have something that considers this.
All
What I
right.
think
So
we might
it's
be
not,
able to make use of is the that 0 operator in discretize. Like that just causes it to skip over so many computations. Like we could actually return that from the sources instead of returning the 0 number.
yeah, but ideally is that if we don't have to loop over sources, we should just skip to not loop over the sources, because just that in Python, if you have thousands of sources, you're just waiting to do nothing, right? You just return 0 arrays. I think if we can skip it all together, that'll be even better. That would be my intuition. Anyway, something to think about next time you do time domain. That's it for me.
Tom, do you have a pull request? I know you've been working on like just the sensitivity matrix for the time domain stuff. Do you have something that could be just like a pull request just for that?
I think so, yeah. I can just isolate it and make a PR. Yeah. I mean, I was still working on it as like of yesterday, but I think at this point it's getting pretty good. I was getting segmentation error with Paradiso. If you give it an array too big to chew on, it can fall over. So I need to be a little careful how big, how big is big. I'm not sure, but yeah, definitely it's a good idea. Should bring it over. I can do that this week.
Soggy?
Not so much on my end. I've been in touch. SimPEG development this week, although I was using it. One question though, Joe, I think I saw that in the current docs for 0.2, the release notes are missing. I saw
Yeah,
PR.
Yeah, we need to retag them, and it just didn't get added to that index.
Okay. Is there
Alright.
anything I can help with that, or it's already done?
What we can do is just have it, like we can have a _ R2 release. It'll cause it to rebuild the documentation. That should be it.
Okay. Is that just the only thing that needs to be done? Could we just like manually add the HTML file for that?
I
Or
think so. You
okay,
could probably do that.
sorry?
You could probably just do that, yeah.
Yeah, okay, I will try that then.
Okay.
Saki?
Yeah, speaking about time domain, I was revamping the time domain code a little bit. So the current form is like we discretize the waveform and then solve like a PDE with the waveform. So I mentioned a couple of times that we could slightly use a different strategy, like you do step off and then convolve. So so I was working with a Korean postdoc working at France. She was interested, so I was helping her, and then we were implementing that. And at the current center, we're very focused on airborne EM. So I think there are a few things that I don't like about the current time domain code is the projection and the way how the field class is working. So it was a little bit it was too much work, I guess, actually fundamentally changing the code. So we started bottom-up approach. So what let me quickly show you.
I'm really sorry, I have to go, but you guys can continue.
Yeah, so let me kind of quickly show you how we were thinking about. So this is so that I pulled out Joe's code which calculates the matrix. So once you got a step off data in enough time span, then you can generate just a linear matrix that you could just simply multiply. Then it does a convolution for you. So all you need to do is accurately calculating the step off. Then you can simply multiply that P matrix that convolves it for you. So what's actually nice about this is the hard part about time domain is always which part of the waveform that I really need to discretize well. And then there's two parts, like waveform on time and then off time as well. So it kind of simplifies the issue. And let me show you. So this is it's in the SimPEG research, so anybody can take a look. So this is the that's sort of the code, how it works, and then so this is similar to, I'm not sure if you use the H3D TD. There's an option that you don't have to store the fields. So sometimes when you're just doing the predicted data, then you don't need to store the fields. So what's happening here, if you are familiar with the code, then what you do is just to calculate the voltage of step off. Then I think then you convolve with this, which is stored in the source, and that's how it's structured. And then you mentioned the sensitivity part. So this we implemented the sensitivity. I think this is a slightly different implementation. But what it does, it's all have a look. I think the current implementation, if you want to actually store the sensitivity, it's very inefficient. So this is kind of a changes what you store or not. So if you look at here, what it stores, like it's a backpropagation. So what you actually store is like this 3 fields of y, and then 3 different steps. So it's a BDF2. So you can just store the number of edge, and then we're storing E field in this case, and then the number of data. So because if you think about the current implementation, if you're using JTVec to form, you loop over each datum, right? And then I think that's
maybe I modified it, but yeah, I stashed it. It's kind of like just doing in the blocks. But yeah, I agree. I understand what you're saying. Yeah.
Yeah. So like there's like then you are doing a time stepping for all the data points. So like it's like solving all of them together for all the data points, because the JT is the number model by number of data. So just choosing the number of data and then solving everything together. I think it's okay, like if your mesh is not so big, but I guess if your system is getting bigger, I think it may not be a great choice. So that's current form. So we're sort of finishing up, and then
sorry. Can you go back 1 sec? Where's your where's the solver called?
I would recommend switching the order of your sources and time stepping, because you end up repeating, like right now that J sigma thing that you had. It was scrolling down there. You're looping over its sources and then over the time steps. So you end up like you like end up refactoring the same A matrix a bunch of times if you have multiple sources.
Correct.
So Dom, I think you shared what you had done a little bit a while ago too. I think you'd done something like that. You'd end up switched those 2 around to get away.
Yeah. The time is the outer outer loop.
Yeah. I think
whatever.
not exactly
It's okay.
Sure why I've done that. I think probably there was some problem. I think like that. Maybe I think that was just my problem. But this was like very specific implementation again for airborne EM. Doesn't matter. You have only a single source. So it's like very specific. It's not going to work for all the problem. And then I think there's another layer, like a 1D code. There's a global simulation that basically runs for parallel. So yeah, for each source, we're parallelizing, and then like to handle like thousands of sources, something like that. So we kind of like I played a little bit with the desk, and then I implemented, but I'm still not exactly sure how like it's gonna work on a multiple nodes. I haven't really had a chance to test, and then that's something that I want to do, and probably I need some help. But implementation wise, that's it. So yeah, like it's pretty simple, either multiprocessing or task implementation. So, and for Ford, and then the sigma calculation. So I think the mechanics is ready. The current post testing, so we'll see. That was kind of what I'm working on.
You should check out those.
Yeah, the new simulation class, right? That that's the plan. So Joe, do you have something like this sort of like already there, so I don't have to kind of rewrite this? Is that the idea?
That's the idea, but the thing is, it handles it on a different level. Like there's multiple. It never brings everything back to the main thread. Does that make sense? Like it never, you never collect all the fields objects and put them together. It kind of distributes everything for you when you need to.
And just pointers.
Okay. Yeah.
Interesting.
So it's like it just manages a bunch of processes or a bunch of simulations acting together to do one thing.
Okay.
So the only thing, you just need to set up each simulation and then tell how to give each simulation its model.
Okay, I'll check that out. yeah, we just finished testing it, like the sensitivity for it, and so we're very open to any available resources to use.
Yeah, like there's no sense in bringing the J matrix back. Just leave it on all of those little processes and have it do it in general. You know what I mean? Like unless you actually need to look at the values of the J matrix itself.
True. So the current way it works is I send like my I assign to children to calculate the J and then pull that out like a pull it to what is that, the main, and then all the JVAC and JTVAC calculation, because it's you have a like global match and local match, there's a P matrix involved. So that all that calculation is happening in the main, which I wasn't exactly sure whether that's a good way to go. But do you mean like you're distributing all the other processes as well? Interesting. Interesting. Yeah. Okay.
You just
cool.
give them all the same model and they know how to grab the chunk, do their work,
Yeah.
and then send back the the update.
Oh,
TDEM.
okay. That's pretty cool. That's pretty cool.
Yeah, it handles it on a different level, at a more abstract level.
Oh, I see. Oh, that's great.
I'm gonna get going to guys, but
Sounds good.
I'll create a PR, but I think it's still great saga for if we can avoid having to discretize the waveform, right? That would be really nice, regardless what happens at J.
So you're doing some strategy where it's like a certain number of like discretizations per decade or something?
Yeah. So I think as you still need to discretize the waveform, like step up waveform. So it's like I do pretty dense like in general. So like it may work for most cases. Well, like for a specific application. But yes, I generate a couple of functions like doing it. It's probably useful.
It's just easier to guess. It's easier to guess how to break it.
Yeah, man, as you go detail, like they're all like a system response and those kind of stuff that you need to implement. I think this way is way simpler to do it.
For sure. Yeah.
And I think that changing current implementation just for the convolution part could be relatively straightforward because it's just like storing that P matrix into the receiver class and then convolve it. So that part may be straightforward, I guess. Maybe not, or maybe or maybe not, because I'm not exactly sure at the moment.
Sorry.
Hi guys.
And can you reshare your screen in the simulation.py file?
Yeah, absolutely.
Yeah, one other thing I noticed, probably this will change after you switch the order of the loops. But it was when you define those those YN arrays.
Okay.
So yeah, so you're allocating 3 arrays that could be pretty big if you have a lot of data points. And so yeah, there's are actually 2D arrays, and you're doing that for each source, right?
Yes.
So, and you're actually reusing those arrays. So you're overriding them at each time step, right?
Yes.
So you can just allocate those 3 arrays outside the for loop. Because
Each
could have different number of datas.
Okay.
No, and then I think I need to set it up actually to be zero. I think that's an important step because like if I'm moving to a different source, it needs to be instantiated as 0.
Okay. Well, but even if you need to set it to 0, if you have the array already allocated, it's way faster to rewrite all the elements than to actually ask for reallocation of memory.
Oh, I see. So something
But
like this.
maybe, yeah, but what Joe said, maybe you're right. Like if you're
because the size, size of the array would change with the number of because each source could have a different number of data. Then then I think it was
okay. So yeah, I don't know how it would look after you change the order, but I was
Hmm.
really take that into account as well.
Yeah, yeah. I think this needs some work. I think that we could potentially change the loop order. I guess so that could help. Well, at the moment, not my interest. we'll test it for some real data and more practical examples, and then come back and read after it. Well, glad to see you all. It's been a while. So Joe, you're at Colorado?
Yep, I'm down in Colorado.
Nice.
Getting things going for a class. Anything else SimPEG related? I can stop recording if you guys just want to chat.
Sounds great. I think I've definitely